This video is for Limits 5, and we're going to discuss how you do direct substitution and how you deal with holes, which we will talk about being removable. When you evaluate a non-piecewise function solely by direct substitution, plug chug, and then the function will be continuous at that point. So, when I look at my first problem, limit as x approaches 0 of 4x minus 2, I directly substitute the 0. I have no issues. I get negative 2, and therefore, this function has a limit of negative 2, but not only that, since I was able to directly substitute, we know that there is a closed circle or has a function value at 0 of negative 2. Likewise, I directly substitute, no issue, and so this one is, the limit exists as I approach 3 and is 9, but also what do we know? The ordered pair 3, 9, that is the function value at 3 will be 9. This is the connection. Whenever you can directly substitute, you're going to have a function that's continuous. So the limit of the quantity negative x squared minus x plus 1 is negative 11. So since it was direct substitution, the function value is also negative 11. The limit as x approaches 8 of the square root of x plus 1 gives you 3. Again, direct substitution. I didn't have to do any other algebra, just arithmetic. And so my limit is 3, and also my function value will be 3. The limit as x approaches negative 2 of x plus 4 quantity squared. I directly substituted, plug chug, out comes 4. So not only is the limit 4, but the function value at negative 2 is 4. So I'll throw in a division. It doesn't seem to matter as long as when I directly substitute that I get a number value. So the limit as x approaches negative 2 is going to be 3. So the function value at negative 2 is also 3 in this case. I did a previous video. Again, for this one, I'm going to directly substitute the 3, and the limit turns out to be 1. It's continuous because it was just direct substitution, so f of 3 is also 1. Yes, trig can come in. The limit as x approaches 2 of cosine pi over 2 is cosine 2 pi is 1. Yes, that's my limit. Yes, it's also going to be my function value since this function will be continuous. I go to another trig function, tangent, plug in the 7. Tangent of 7/4 pi is 45 degrees south of the 360 mark is negative 1. The limit as x approaches pi of secant 2x is secant 2 pi. Remember, secant's the reciprocal of cosine, and cosine of 2 pi is 1. And so the limit as x approaches pi of secant 2x is 1. Sine inverse. When I go to do sine inverse, I directly substitute, and sine inverse of root 3 over 2. Remember, the domain is quadrant 1 and negative quadrant 1. And so when do you get root 3 over 2? And that was not supposed to say pi over 6. It's supposed to say pi over 3. And then, limit as x approaches 1, directly substitute, negative 1/3 is the limit. The limit as x approaches 0 of this quantity, directly substitute, I get 1. The limit as x approaches 9 of the cube root of negative x plus 1, directly substitute, I get negative 2. And the limit, my favorite, as x approaches negative 10 of negative 6 is negative 6. It is so easy, it's hard. There is no x to directly substitute, so what you see is what you get. In all of these cases, because it was pure direct substitution and arithmetic, these will all be continuous, and the limit will be the function value. Now, what happens when we can't do that? Well, we have a theorem, and it talks about functions that agree at all but one point. It says let C be a real number and let f of x equal g of x for all x not equal to c in your open interval. If the limit of g of x as x approaches c exists, then the limit of f of x also exists, and the limit of f of x as x approaches c and the limit of g of x as x approaches c are the same. It is this theorem that allows us to deal with the indeterminate form of 0 over 0. Now, 0 over 0 will require more algebra, and for this worksheet, these will always, the indeterminate form, represent discontinuities. Now, the majority of the worksheet's going to look like the first example and the last example. We do have two piecewise problems, but sadly, neither one of them came out to be wholes on this particular worksheet. That will happen on worksheet 6 when we get there. So, to deal with our wholes, the only algebra we will be required to do today is factor and reduce before we do direct substitution. Please note that since we must factor and reduce the whole before direct substitution, this is not continuous. Now, folks, you must show proper work. This is not multiple choice. You will receive a sheet entitled Do You Want Credit? Do as the sheet states or no credit. You did it all for fun. You want to do it for fun? Be my guest. Now moving to the next room where we have the rest of our examples. We're going to do examples of when we have 0 over 0. You're going to have to factor, reduce, and do direct substitution. You have to show all work and remember Ma, M-A, means more algebra, not mama. So in my first problem, the limit as x approaches -2, that means as x gets closer to -2 but never getting there, of the function x squared minus 4 over x plus 2, note x cannot be -2, but we're near, this is near, so we're not worried about that, is 0 over 0 requiring more algebra. So I factored, and then I reduced, and now I'm ready to do direct substitution. But notice I'm doing direct substitution after I've done algebra reducing. So, -2, -4 represents a hole on our graph. The next problem, we're going to have to do more finagling. You're going to have to rewrite this as negative the quantity x minus 3, factor the x squared minus 9. Notice again, this says near, which is what allows me to cancel, not at. We know the function itself can't be 3 or -3. I cancel, which means I'm creating a hole. And now I do my direct substitution and I get -1/4. What's my hole? 3, -1/4 will represent a hole on the graph. For the third problem, get my finger out of the camera. Notice again, I'm near 2, not at 2. I'm not allowed to be at 2. But when I do plug in 2, I get 0 over 0, which is more algebra. So I factored. And now after I factor, I can reduce. And now upon doing direct substitution, I get 5/4. Therefore, I'm not continuous. I have a hole, and my hole would not be at 0. I don't know why I wrote 0. It would be at 2 5/4 on the graph. Another problem, another instance. I need to factor. I get 0 over 0. Well, I have to do more algebra. Now be sly, folks. If you have 0 over 0, x plus 2 must be a factor. So I went ahead and put x plus 2 here and said x needs a 3x. And 2 needs a -1 to make it -2, because the only way you get 0 over 0 is if these two polynomials share a factor. So now I can cancel. I'm not going to spend time doing grouping when I don't need to. And so upon direct substitution, I get -7. But note, this means that at -2, -7, there's a hole in the graph. Next problem. We're going to have a difference of cubes. Again, near, so it's okay for me to cancel in a minute. But the actual function itself, I cannot have 3. I have 0 over 0. Remember, after you factor your cube, you square the first, square the last, first times last, negate. So now these cancel, and I get 1 over x squared plus 3x plus 9. Note when I plug in 9, 9, 9. Yes, that's a pattern when you have a hole. Whatever the final integer is, that all of them will be. So I get 1 over 27. So note my hole is going to be 3, 1 over 27, because I did have to reduce. Next problem. What happens when you see x to the 4th? Well, it's x squared plus 4 and x squared minus 4. Notice I just went ahead and factored the x squared minus 4 to save room. There's only so much space here, folks. I'm near 2, not at 2, because this is a limit. Limits say what's going on near. Now that I'm factored, I can reduce. Now I'm ready to do direct substitution. And notice I get 32, which means I have a hole at 2, 32. Now, why are holes referred to also as removable discontinuities? Well, here's the pictures that I had on the first page. Since all I must do is change a single ordered pair, and then the graph is going to be continuous, the hole has been eradicated or removed. So notice, plug it in, change its place, change its place, change its place, change its place, plug it in, and then voila, it's going to be continuous. This is why we talked about the theorem. They differ at all but a single point. Here's the continuous graph that we directly substituted in at the very end of the problem, and this is the original problem before we factored and reduced. So holes are akin to continuity in the fact that they can be repaired if you define or redefine the ordered pair. Now, before we move on to the rest of the stuff, do you want credit? Please understand that limit as x approaches c or a of a function is an operator just like the plus sign, the minus sign, the multiply sign, the divide sign, the square root symbol, the radical, the cube root radical, the quantity squared, the quantity cubed, etc. The operator disappears once the operation has been completed and not a step before this. So notice 2 plus 3, once it's 5, I no longer see the plus. 5 minus 1, once I've subtracted, I no longer see the minus. The cube root of the quantity 3 squared minus 1, I no longer see the square once I square and get 9. I no longer see the subtract once I subtract and get the 8. I no longer see the cube root symbol once I do the cube root and get 9. The absolute value of 1 minus 4 divided by 2 minus 2 times 3. Well, once I do 4 divided by 2, there is no more division symbol. Once I do 2 times 3, there's no more multiplication symbol. Once I add the -2 and the -6, I have only one minus symbol. Once I do 1 minus 8, I simply have a -7. And when I do the absolute value, the symbol disappears. Now, just as in these examples, the limit as x approaches a quantity must remain as a symbol until we are able to apply direct substitution. So, a legal way to show your work. Notice how I showed all the steps neatly, cleanly, like I'm a textbook and I can reduce and rewrite. You say, but I'm a bum. So then you can just rewrite, put the 1 up here, and then direct substitute. Or you say, I'm really a bum. I'm going to mark out the denominator. I'm going to go ahead and factor, and then I can cross off these, put a 1 there, and now I'm going to be 1/2. What you cannot do is you cannot say the limit equals, woo, the limit's missing, and now I'm 1/2. There is no operator right there. There is nothing that tells me that my answer is anything other than 1/x plus 1. This is 1/x plus 1. I need limit x approaches 1 to be able to substitute. Limit x approaches 1 must be there. So this is not legal, and you did it for fun and no credit. The next problem, again, I can show all the work completely. It's just beautiful. I can cancel. There it is. I can do direct substitution. Beautiful textbook style. What somebody wants to show that's teaching. Student style, I factor, I cancel. And now that I've shown the cancel, I'm going to plug in. Student style. Gee, I don't even want to rewrite it. It's really easy. I'm just going to mark that out and put what the factors are up above. I'm going to cancel, and now I'm going to direct substitute. All of these are legal, but I can't do this and off to the side write this, or I can't write this underneath. Just put this right here underneath. I have to have limit. Otherwise, all this tells me is x plus 3. And if I wrote it underneath like this, and then tried to cancel, and it just tells me x plus 3. I can't show that. I must write limit until I'm ready to do my direct substitution, or there is no credit. You did it just for fun. Now, the last 2 problems that made on this worksheet were piecewise. And the first problem turns out to be continuous, and the second one is a jump. It got onto the wrong sheet by mistake. It was supposed to be a whole. Deal with it. So, now something that we need to remind ourselves of and learn is that here is your number line. And here's -2. Here's the left side. Here's the right side. Over here, we're less than, and over here, we're what? Greater than. So, the first time I see the 2, I'm on the left side. The second time I see the 2, because it says greater than, I'm on the right side. So when asked me to find the limit as x approaches 2 from the left, I say, what's your first appearance 2? And I directly substitute. Then it says, find x as I approach 2 from the right. What's your second appearance 2? It said 8 minus x. I directly substitute and I get 6. Since they're equal, my answer is 6. My function value is wherever the equal symbol is, and since it's paired with the first one, its answer is 6. And since c and d are equal to each other, I am continuous. Now, this last one was to be a whole, but alas, it will be a jump. It's a mistake. Oh well, again, live with it. Notice this is the first appearance of -1, the second appearance less than, greater than. So the limit as x approaches -1 from the left. I substitute in -2x minus 3 and get -1. As I approach -1 from the right, it's the second one. I write it up above. I substitute and get 1. Alas, it's a jump. D and E. In this case, the equal sign's at the bottom, so the function value is going to be 1. Sorry about that being on the wrong sheet. Now, your notes, you're going to see many of these examples, but not all of them, in your notes from 18 to 21, and also the first 3 examples on the top of page 26.